I may be a bum, but I'm not dumb. It's time for a bum knowledge corner. When I was a kid, I used to watch a show called Recess. In one episode, The Teacher's Lounge, the main cast speculates on exactly what happens in the teacher's lounge because, kids weren't allowed in there, so they let their imaginations run wild. The intellectual of the group, Gretchen, theorized that the teachers did things to advance academia, such as finding a rule for multiples of 7. Ever since then, I kind of wanted to figure one out myself. About a year or two ago, I actually saw a YouTube video on the Numberphile channel where they actually talk about that there is now a rule of 7 to figure out if something is a multiple of 7. And that kind of made me sad. Later on, I found another channel, Wrath of Math, where they're talking about exactly how does the rule for 3 works. And they basically broke it down to it's not the 3 that has the rule, it is the 9 that has the rule, and the 3 just works because it is a multiple of 9. I was like, oh, that's interesting. And they also go into more detail of like why does 9 work, and they then went through all the different bases. So they did start off, of course, with base 10, and then went on to base 9, base 8, base 7, and they showed that when they shifted it, it actually um, 8 works like a 9 when it is base 9, and 7 works for it when it is base 8. Simple. So then I started thinking about it, and I started fusing the two ideas together, and then I came up with this. So, what I have done here is done the entire process because this is what I figured out is basically a universal um, rule for figuring out whether or not something is divisible by something, with a little bit of a caveat at the end. So you remove the first number that's in this box. I do that by doing a integer multiplier, and I just multiply the entire thing by 0.01 or 0.1. And integer is a thing that will only return full values, so nothing after the decimal. Then after I do that, I just subtract the first number that I had here by and subtract this one times 10 because it's already been removed by 1, and so I times it by 10 to have it. That this gives me the first number. Then I multiply by the complement. So I will multiply it by this number, and then I get the new value, and we get here. Since I was talking about divisibles by 7 as a rule, let's start with that. Put that in there, hit enter, and so now we can actually see the process a little bit better. So I do this by, so these are just multiplying it right off the bat, because then we know that it is for certain multiple of 7. And let's go for this line. This line, we remove the first number, so the 8 is not there. There's the 8 on there, so And if you look down here, it's the 9 is there and the 11 is there. That's basically all this doing, is just removing the first number. Now I multiply this one by the complement, which is 3. The 3 times 2 is 6. And then I add this one again, and 8 plus 6 is 14. So, and that goes into it evenly. Now I have this one right here, just that's not an automatic multiple, so we can look at this. So let's go to prove that it actually works, and it just doesn't work automatically no matter what you do. It's like a self-fulfilling prophecy type of thing. Let's put in 13 in this one. As you can see, it returns a value that is not. And we can do it for 15, also not. So it does work. Like, yeah, let's just go through an entire thing. 15, 16, 17, 18, 19, 20, and 21, and that should be working again. See? So if you're looking over here the entire time, you would notice that it only returns it when it is a multiple. So this works. This works for everything. But yeah, much to my surprise, this is kind of like a universal one, because if I did this by 6, it all works on all of these, and it doesn't work on this one because 6 does not go into 21. So you can use this for multiples of 6, multiples of 5, same type of thing. It's off by that much. And yeah, so, and we can even go -2, and it will work. So this is kind of insane because it works full on everywhere. But you might understand that this isn't actually 100% foolproof. Because of one small issue that you might be able to see. If we go, for instance, 33, well, we start with 33, but our new multiple is 66, so it's actually growing. So that's the little caveat. It does work for all of them, but after you go above 20 and below 0, the numbers start actually becoming bigger. And that's not the greatest thing to work with. But yeah, you can see that is 23. Okay, so that is above. So since I went above 10, it is actually going into negative numbers. So you would multiply it by a negative number, and then it goes there. I guess you could make it so this is, you could use the absolute values of these at this point, but I think it would, but since you have to add the first one to this one, like this is, of course it is. So this first one we have 69, and then we subtract to, or then we add this back to that, and then of course, which makes it 66. But yeah, so, but it still works all the way through on all the other ones. It's kind of insane that it does work like that. And yeah, that's how I found a new way of finding the finding a brand new rule for not only division of, or if something is divisible by 7, but for everything, which is actually really cool. What was this part for? Hmm. Oh, okay, yeah. So this just shows you how it runs downwards. So if you do it for this one, you get here, that's the new one, or it gets it over to here, then it goes over here, runs through it again, runs through it again, runs through it again, until it gets to the very bottom. And like I said, after you get to 23, it actually starts getting bigger and bigger and bigger. The same thing when it is it -3, it starts getting bigger and bigger and bigger. So that's the only like downside to this, and I don't know if there's a way to mitigate that. I'm almost certain that I discovered this. I don't really have access to any of the stuff that most people are. Well, I have access to it, but I'm not really connected to the wider span of mathematicians. So I don't really like, I'm not part of the mathematic community. So I don't know if someone else has already found this before. But I just find that really interesting that if you multiply everything 10 or everything above the base by the complement under the base, that it actually, and add it back in, that it actually gives you the answers. I think it's cool. So that'll be it for this. I hope you enjoyed my first mathematical kind of proof, I guess, that this works. Most people will probably still stick with the methods of finding out whether or not it's a multiple of 7 by Numberphile, because it is a little bit simpler, but I just wanted to showcase that I I actually succeeded in something that I wanted to do as a kid, mostly. Because I found my own way of coming to the same conclusion, more or less. And and maybe this will be useful in future things if anybody else actually picks it up. So thank you for watching my funny little thing. I'm the car bum. Now get off of my corner.